We're talking about in this chapter is a lot of solving equations. And we're going to start very basic. We're going to start with one step. So you have one thing to do to solve an equation. What we need to talk about to get you there is a couple of properties of equality. And you're going to see these a bunch. And maybe you already know them, but we're going to just talk about them just to be sure. So the first two properties that we're going to talk about are called the addition property of equality. Any guesses what the other one is? If we're talking about addition, we're also going to talk about subtraction, okay? So the addition property of equality, we're going to start there, says that for any real number, so if we have A, B, and C as real numbers, we can say if A is equal to B, then if I add something to A and I add the same thing to B, I'm still going to have equal parts, okay? So if A equals B, then let's say we add C to both sides. So A equals B, we're just going to add a C on the left, add a C on the right. They will still equal each other, okay? Think of it this way. If I say 6 equals 6, right? So I have two numbers, 6 equals 6. If I add 2 to both sides, 6 plus 2 equals 6 plus 2. Now they both equal 6 plus 2. Now they both equal 8, right? So they're still equal because we added the same thing to both sides. That's what you're going to use in solving equations, which might sound a little silly right now, but you'll see. Okay, so that's what the addition property of equality says. And then there's the subtraction property of equality. And this one just says if you subtract the same thing from both sides, you'll still have equal parts, okay? Micah, are you taking notes on that? What are you doing right now on your iPad? What are you doing on your iPad, Micah? Okay. So the subtraction property of equality says if A equals B, then if I take C away from A and I take C away from B, they will still be equal, okay? So that's the subtraction property of equality. I'm going to show you how we do that in just a minute, but there's a word that's going to come into play a ton. Do you know what it means to isolate? If I say isolate yourself, what are you doing? Do you know? By yourself, right? Isolate. Get it by itself. Get you by yourself, whatever. However we're talking about it. So you're going to see the word isolate a lot. You're going to hear the word isolate a lot. So when we say isolate a variable, okay, what I mean by that is get the variable by itself. Okay, so if I had like x equals 2z plus 4, we would say that x has been isolated. Okay, it's by itself on that side of the equal sign. So when I say isolate, think get it by itself. Make it so that it's the only thing on that side of the equal sign. Okay. So tell me this. If I give you x equals 6, has that been isolated? Has the variable been isolated? Yes. We would say yes, this is isolated because the x is by itself, right? What if I said p plus 5 equals 8? Has the variable been isolated? No, why not? It's not by itself. This 5 right here Makes it so that it has not been isolated, okay? What if I said 3m equals 7? Has your variable been isolated? No, right? Because there's a 3 in front of that m. So this would be, sorry, I just flip-flopped how I was writing them. That would be no also, okay? So we want the variable to be by itself. Here's what we're going to do. We're going to use these properties to isolate the variable and solve for whatever that variable is, okay? So let's say my equation looks like this. X plus 13 equals 27, okay? Now, the subtraction property of equality says if I subtract something from the left side of my equation and I subtract the same thing from the right side, then nothing changed. We are still equal, right? Okay, well right now I'm saying x plus 13 equals 27. So if I want to get x by itself, I need to do the opposite of what I'm doing right now. So right now I'm adding 13. What would the opposite of adding 13 be? Subtracting 13, okay? So what you're going to do to isolate the variable is you're going to take 13 away from both sides. Now look at what happens when we do that. And I always put a bar here just to show, like, here's what came of it. You don't have to put the bar, but if it helps you, go for it. What is 13 minus 13 on the left there?
0.
0. So this goes away, okay? You don't need to write a 0 there. Just leave it. Nothing there. So what's on the left side of my equal sign right now? Just an x. So has my variable been isolated? Yes. So then on the right side, we're going to say 27 minus 13 is 14. So when I ask you to solve for x, you would solve and get x equals 14. Okay, now you can always check your work by going back and plugging it into the original equation. So if I plug x in as 14, 14 plus 13 should equal 27, and it does. So that's how we know that it checks out, okay? So that's a one-step equation. All we had to do was one step. We had to subtract from both sides. How about this one? If I give you negative 7 equals b minus 3, okay? Where's my variable? B, okay? I want to isolate my variable, so what do I have to get rid of?
3.
That minus 3, right? Now, right now we're subtracting 3, so the opposite would be to do what? Add 3. So you're going to add 3 to both sides of your equation. Dustin, are you with me right now? What's on your iPad? Because you haven't looked up from that for a while. Put that away. So we're going to add 3 to both sides. Plus 3 here, plus 3 here. This now, the negative 3 plus 3 is what? 0. It's gone. Negative 3 plus 3 is 0. So that's gone. We're left with a b on the right side. You bring down your equal sign. And now here's where you have to be a little bit careful. What is this going to equal? Negative 4. You have negative 7 plus 3, right? Be careful with positives and negatives here. So negative 7 plus 3 is negative 4. That means my b value is negative 4, okay? So if you were to plug it back in, negative 7 equals negative 4 minus 3, and negative 4 minus 3 is negative 7, so then you know that it checks out. Good on that? So you're adding or you're subtracting. You're doing the opposite of whatever is already happening in the problem, okay? That's called an inverse operation. I'm not so concerned that you know the name of it, but that you're doing the opposite, okay? That's what you're going to do all the time is do the opposite. Damon, are you doing homework right now? Don't do homework right now. I want you to get this. Okay. Any questions on addition and subtraction with this? All right, then the next two properties are multiplication and division. So it's the multiplication property of equality, okay, and the division property of equality. Okay, we're going to talk about both of them. Now think about what addition and subtraction said. If we add the same thing to both sides, they'll still be equal. If we subtract the same thing from both sides, they'll still be equal. With multiplication and division, it says the same thing. If we multiply both sides by the same number, they're still equal. If we divide on both sides by the same number, they're still equal. Okay? So what we're going to do for this one is if we have... let's say for multiplication, we have x divided by 3 equals 2, okay? What it's saying is if I multiply both sides by some number, I'm still going to get equal parts. Well, in order to isolate, in order to get x by itself, right now it's x divided by 3. What's the opposite of division? Multiplication. So we're going to multiply by 3. And multiply by 3. This is basically now saying 3 divided by 3, which is 1. And multiplying by 1 doesn't change anything. Okay? So on the left side, we have isolated. We just have x. On the right side, we have 2 times 3, which is 6. So that's how we're going to solve with the multiplication property of equality. Basically, we're saying if A equals B, then A times C will equal B times C, right? If A equals B, then A times C equals B times C. Okay, that's multiplication property. The division property says if A equals B, then A divided by C will equal B divided by C. So for that one, we're dividing by something. So like if I had 2 times x equals 12, and I wanted to isolate x, you have to ask yourself, what am I doing with 2 and x right now? I'm multiplying. So to do the opposite of multiplying would be to do what? Divide. So if I divide by 2, that's 1. Divide by 2, I get x equals 12 divided by 2 is 6. Okay? Questions on that? Okay, so we're going to do a few with multiplication and division right now. So this is example 3. Let's say I give you the problem 4x equals 6.4. Okay? Right now, what's happening between the 4 and the x? What operation? Multiplication, okay? You always do the opposite. So what's the opposite of multiplication? Division. So we would divide by what? By 4. You want to cancel it out. So when you divide by that same number. 4 divided by 4 is 1. So essentially we have 1x, which we are just going to call x. Okay, and then 6.4 divided by 4 comes out to 1.6. How do you check your answer? Plug it in. You can plug it into your calculator. 4 times what you got, 1.6, should equal 6.4, and it does. 6.4 equals 6.4. So then we know it checks out. Okay? How about this one? If I give you x divided by 4 equals -9. Okay, what operation is happening in the problem currently? Division. What's the opposite of division? Multiplication. What are you going to multiply by?
4.
Multiply by 4. So whatever, we're trying to isolate the x, right? So to get the x out of there, or to get the 4 out of there, we're going to multiply by 4. And multiply by 4. So 4 divided by 4 is 1. That's gone. So I get x equals what? What does this come out to? -9 times 4. Positive or negative? Negative. And 9 times 4 is 36. Right? So if I plugged that in, -36 divided by 4, it should equal -9, and it does. Okay? Okay? So isolate. Get the variable by itself every single time. All right, I got 2 more examples, and then I'm going to throw a whole bunch up on the board, and you guys are going to try a couple. Example 5. Let's say this one looks a little different. Okay, so the difference here is you are doing 4/5 times m, right? Another way to think of it, to get rid of it, right now we're multiplying, so to get rid of it, we'd have to do what? What's the opposite of multiplying? Divide, okay? Remember the saying? When dividing fractions, don't be shy.
They multiply another guy.
Flip the second guy and multiply. Essentially, you are multiplying another guy. So here's the deal. If we're going to divide by 4/5, we're actually going to multiply by what? 5 over 4, okay? So you're going to multiply by 5 over 4 on both sides. So that means 5 divided by 5 is 1, 4 divided by 4 is 1, so that's gone, right? That gets rid of it for us. So on the left, we have isolated, and we just have m now. On the right, you could multiply across, or what I would do, just to simplify, is I would cross cancel a little bit. So 28 and 4 are both divisible by 4, which gets us 1 and 7. So what is 28 times 5/4? 7 times 5 is 35. Okay? Yes, I'll do another one of those. How about if we had 2/3 x equals 6? Okay, right now we're multiplying by 2/3. We want to divide by 2/3 then. How do you divide by 2/3? Flip and multiply, right? So we're going to multiply instead by 3 over 2 and 3 over 2. So this cancels and this cancels. You all right? So 6 times 3 over 2, you can make that 6 over 1. 6 times 3 is 18. 1 times 2 is 2. What's 18 over 2? 9, right? 9 over 1, which you can just call 9. So your answer would be 9 there. Okay, so when there's the fraction and you're multiplying, you need to actually multiply by the reciprocal because you would be dividing by that fraction. Okay, questions on that? Okay, I want to go back to one like example 4 because example 4 and example 5 look similar. And now that you've seen them both, I want to make sure you're good on example 4. Okay, so if I gave you something like this, x over 2 equals negative 11. It looks like a fraction, right? You do not multiply by 2 over x. Does anyone know why? Why don't I flip this one?
Because it only has...
It has the x, right? We're trying to get x by itself. So if we multiply by the reciprocal, x goes away. We don't want x to go away. We want x to stay there. So what do I multiply by instead? You just multiply by 2 on this. Okay, so multiply by 2, multiply by 2. This goes away, and x is negative 22. Okay? So just be careful. If it has the full fraction in front, multiply by the reciprocal of that fraction. If the variable is on top and the number on bottom, just multiply by the denominator, and that will get rid of it. Okay? Okay, last thing. This one's a word problem. We're going to make you like them a little better. Here's what it says. That's not a blast. That's an encouragement. The length of an average toucan, that is terrible, is about 2/3 the length of an average macaw. Okay, it says toucans, you don't have to write the whole thing, are about 24 inches long. What is the length of the average macaw? Okay, lots of words, right? Don't let the words stress you out. I was working with my son on his math yesterday, and it says, how do you solve a two-step problem? Well, this one's only one step, but your process is find the words that matter, right? So in this problem, it's talking about the length of a toucan, right? What's is in math? Equals, and then 2/3, and then it's the length of a macaw, right? So if we turn that into an equation, could anyone tell me what that would look like? If we call a toucan T and a macaw M, how could you turn that into an equation? Hey, don't discourage. At least she's trying, right?
Okay.
Yes.
T equals 2/3.
Mm-hmm.
And M equals.
You're close. T, okay, look, listen. The length of a toucan, right, that's T, is equals, and then 2/3 of the length of an average macaw. So the length of a macaw is M. Can you tell me what operation we should do with the 2/3 and the M? Are we adding, subtracting, multiplying, or dividing? If something is 2/3 of the length. Do you know what of often means in math? When you hear the word of, it is often multiplication, okay? So we're doing 2/3 times the length of a macaw. So that's the equation you would come up with. And then we need to solve it knowing that toucans are about 24 inches long. So where's that 24 going to go? 24 will replace which variable? T, right? A toucan is 24. So we're going to put 24 here. So 24 equals 2/3 M. How do you solve that? This is like example 5. If 24 equals 2/3 M, what do I have to do to both sides?
You divide.
You have to multiply by what? The reciprocal, right? You got to flip it. Because essentially, here's what's happening, guys. Listen. Essentially, you're dividing by 2/3. Well, if we're dividing by 2/3, we're actually multiplying by 3/2. So we're going to take this away, and we're going to multiply by 3/2 on both sides. Okay? So this cancels, that cancels, and we're left with M. Now you just need to simplify this. So 3/2 times 24/1. And again, you can multiply across right now, or you can cancel if you want to reduce a little bit. So 24 and 2 would be 1 and 12. And then you just multiply. What's 12 times 3? 36, right? So the length of an average macaw is 36 inches. Okay? Questions on that? We're going to do some on the board, yes.